All right. Good morning or good afternoon, everybody. I will try to keep this video a little bit shorter, but if it's not, you can always speed it up. Uh, so, types of chemical reactions. This is going to be a two-part lesson. The second part will be done when I come back. Right now, I am somewhere on the KVR. This will be the first part, and we're going to be covering the first three types of chemical reactions and how you will predict the products of these reactions and recognize them. So our first one we're going to be talking about is the synthesis reaction, and this is probably one of the easiest ones. Synthesis just means to make or to synthesize, and it's when we have two, generally two, there can be more, but in our examples at grade 10, you'll only see two different elements that are going to react together to form some larger molecule, and there's only going to be one molecule that it forms, meaning that see, we have here in our first example, we have our hydrogen gas, oxygen gas, and they react to form the product of water. So we have two simple on their own elements, and they react together to form a more complex molecule, such as water. Okay? Right now, I know there's quite a lot going on. Just ignore the big balancing coefficients. These reactions have been fully balanced. We'll talk about that a little bit later. Okay, I just want you to focus on the element themselves and then the molecule. Our next example, we have sodium, which is an alkali metal, right, that we're familiar with. Those are quite reactive. And then we also have chlorine gas, which is toxic, famously used in the world wars, right? In trench warfare. And it's kind of crazy. This is one of my favorite things about chemistry, is that you can take two things that normally on their own are not great for a human being, toxic chlorine gas and a very reactive metal, and you can react them together to form something that everybody consumes daily and we actually need for properly functioning cells, or sodium chloride, right? Table salt, right? So those are types of synthesis reactions. So we basically, whenever you're trying to predict, and when you predict a reaction, you'll generally only be given the reactant side, right? You won't know the product. You'll have to predict the product. So for example, on a test, or practice problems, you'll be given the reactants, and I will ask, how do you know this is a synthesis reaction? Well, first of all, that there are two different types of reactants, right? So this is A and B are just variables. So two different types of reactants that are coming together to form something, and also that these different reactants are going to be simple elements. So whether that is a metal or that's a non-metal, and they're going to be coming together and joining, okay? And we'll talk about how they join together and how you actually predict the product in a second. But I do want to emphasize here that our hydrogens and our oxygens, it's not just hydrogen, there's a subscript and a subscript of 2, and that's because these are what we call diatomic. And I know I mentioned the word diatomic quite a few classes ago, and if you don't remember, that's okay. We'll talk about it now. So diatomics are certain elements, there are 7 in total, that are going to be nonmetals, and on their own, they are incredibly reactive. So they can't exist only on their own. They will seek out and find another one of them. So for our hydrogen, for example, hydrogen can't exist as one singular hydrogen atom. It has to find another hydrogen atom to bond with in order to be relatively stable. Our metals, for example, are totally fine existing as a singular atom and floating around, but our 7 diatomics, that's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, must exist as a diatomic with a buddy when they are on their own. If they are in some sort of molecule, larger molecule, such as H2O H2O or sodium chloride, these rules don't apply because now there's another element they can bond to. Only when they're on their own must they have that subscript of 2. So just be aware of that, because that's something that quite often tricks people up, or they forget about that, and that would mean you got the question partially wrong. Okay, how do we actually know what to write the product as? How we solve these, and let's take sodium chloride as an example. We already know what it forms, but how do we know that? So sodium plus chlorine, okay? Sodium and chlorine, both small elements. We know this is a synthesis because there are 2 of them. They're small elements. They must come together to form one larger molecule. Okay, what is it though? So what I want you to do when you're trying to solve these problems is just look at the elements. Don't worry about any larger subscripts, or even our, or our subscripts. I meant coefficients. So don't worry about coefficients, don't worry about subscripts, okay? I only want you to worry about the elements. Okay, so we know we have sodium, we know we have chlorine. So let's write that on the other side. So sodium and chlorine, they're going to join together. But we have to do something I like to call charge balancing. Basically what that talks about, or what that means, is that we have to make sure that the molecule is going to be stable, that it's going to exist. Otherwise, sometimes in chemical reactions, you can put 2 things together, but because the final product is not stable, it won't form. So we do this by looking at its ion charges. And you would have learned about the swap and drop or the crisscross method sometime in grade 9, but I have included a written explanation as well as a video for you to check out if it's still very unfamiliar. We talked about this earlier as well. So what I want you to do is take a look at your periodic table, okay? And you're going to find what the charges on each type of element. So sodium has a +1 charge, and chlorine has a -1 charge. All right. So what you're going to do now is you're going to do the swap and drop or crisscross method, whatever you would like to call it, where you're essentially going to take the charges, and in order to find how many of each sodium or chlorine is going to be in this molecule, we're going to take their charges and we're going to basically take the absolute value of it, the positive value. So you're going to drop the charges. So you're going to drop the positive, you're going to drop the negative, and you're going to cross them over. Okay? So chlorine's charge, again, we're going to drop the negative, is going to, so it's just 1, it's going to come down behind the sodium. And our sodium charge, we're going to drop the charge, which is positive. I mean, it's going to stay positive. And the 1 is going to come down behind chlorine. So we end up with sodium fluoride. And this is balanced. We can double check to see if it's balanced by basically seeing if the total value of charge ends up to be 0. This trick won't necessarily work for higher level chemistry, but for grade 10, this will be totally fine. So let's see, we know we have 1 sodium if we're counting our molecules right, or our elements right. So we have 1 sodium. What's the charge on sodium? We know it is +1. Okay. We have 1 chlorine. And what's the charge on chlorine? It's -1. Okay. If we're going to solve this, 1 times 1 is 1, plus 1 times -1, that's -1. So it would equal 0. That means we have a neutral molecule and it is stable. So you're going to do that when you are solving, when you are forming the product. Balancing, when you're using the big coefficients, comes later once you've predicted the product. So remember, this is, you can call it charge balancing to make sure that the product you're forming is stable. And then balancing the whole equation is when you use the big coefficients to make sure you have the same number of each atom on both sides. And remember, don't carry your coefficients, or sorry, your subscripts over when you're balancing. Only look at the individual elements, okay? All right, so I want you to go ahead and practice with this one. So Mg plus I2. So pause the video here, go ahead and try to solve this, and then I will solve it with you. Then you can come back and check if you got the correct answer. All right, hopefully you have all tried to solve this. So the answer would be, again, take our individual elements, Mg plus I, right? We're not carrying over the subscript of 2. We're going to look at, so Mg has the charge of plus 2, and we'll get rid of this circle here. So Mg so Mg has a charge of plus 2, and iodine has a charge of -1. Okay, so we're going to do our crisscross method. Our 2 is going to come down behind the iodine, and our -1, we're going to drop the negative, make it a positive, and it's going to come down behind the magnesium. All right, so we end up with MgI2. And if you want, you can go ahead and do our mathematical check. Not super needed. I know that this is a stable compound, but if you would like to double check, go ahead and do so. All right. Let's talk about decomposition. So decomposition is the opposite of synthesis. This is where you have your molecule and you're ripping it apart. Okay? So you're breaking it apart into 2 smaller elements or atoms or molecules. All right? So you can always tell what is a decomposition by seeing that if the reactant is one singular molecule, then you know that you are going to be taking it apart. All right? So again, we have the exact same elements that we have, or molecules examples that we have from the synthesis, just in the reverse, okay? With this, you don't need to do your crisscross check because again, you're not forming a molecule, you're just taking apart the molecule and you're forming the individual elements. You need to just make sure though that you remember on all of the diatomics, you include that subscript of 2. Okay? All right. So let us do an example. Let's try, we'll try our example will be CO2. So again, pause this video and go ahead and try to solve what are the products of this decomposition reaction. All right, hopefully you have tried to solve this. Let's go ahead and break it apart. So with the decomposition reaction, look at what elements you have. We have carbon and we have oxygen. Okay, does carbon need to be with a buddy? So carbon is not part of our diatomic. So carbon can exist on its own. We have oxygen. Does oxygen need to be part of a diatomic? So does it need a buddy? And yes, it does. So that means our final product, predicting products, would be C plus O2. All right. So let us go to our final reaction we're going to be talking about, combustion. So combustion is a relatively easy one, probably easier actually than both synthesis and decomposition, purely on the fact that the product is always known. It's just recognizing what is a combustion reaction and then doing the full balancing of the equation. So that means the large coefficients. And why it's difficult is because you're dealing with what we call hydrocarbons. So hydrocarbons, which are something that if you get into organic chemistry, you'll be learning a lot about. Those are any sort of molecule that consists of carbons, and I'm just using variables here, so placeholders. So X, hydrogens, let's do Y, and then oxygens, let's do Z, okay? So hydrocarbons are anything that contains carbon, hydrogen, or oxygen. If it contains, for example, if you have carbon, hydrogen, and bromine, that is not a hydrocarbon. It has a bromine, and so no, it's no longer considered a hydrocarbon. But if you only had carbon and hydrogen, yes, that is a hydrocarbon. If you have carbon, hydrogen, oxygen, yes, that's a hydrocarbon. So when you are figuring out what a combustion reaction is, you're going to be looking for some sort of hydrocarbon, so a mixture of carbon, hydrogen, and oxygen. Doesn't necessarily have to have oxygen, plus our oxygen gas. That's an important one. If you see those two things, if your reaction question checks those two boxes, that means you have a combustion reaction, and the prediction of the product is super easy because all combustion reactions will always only produce, in general, there are exceptions, but in our case, in Science 10, it will only ever produce carbon dioxide and H2O water. You do not need to do any cross and drop, anything like that. They will always only produce carbon dioxide and H2O water, okay? So if we have our example, right, CH4 plus our oxygen gas, remember the oxygen gas is important, we know automatically it's CO2 plus H2O. The difficult part here is balancing the large coefficients at the front, because you can see quite quickly we can get large numbers of carbon, hydrogen, and oxygen, and that's where the balancing and the math gets difficult because you can get large coefficients really, really quickly. Okay? So what I want you to go ahead and do now, since we've gone over the first three examples or first three types of reactions, we're going to do some more practice. There is a card game or tic-tac-toe that I've made for you, and I want you to practice that, as well as there are tons of different questions that I have included on here, as well as an answer key. So go ahead. There's also escape room, but that is for once we've covered all the different types of reactions. You won't be able to do it completely with just the information you have here. So go ahead, try out the game, and then once you're done, try practicing, predicting what type of reaction is, predicting the products, and then balancing the whole equation. All right, and check yourself with the answer key. All right, take care. Hopefully this helps. Bye-bye.